The next time value of money application we investigate here is the loan amortization problem. An amortized loan is a loan where the principal of the loan is paid down over the life of the loan. So this process is called amortization. A mortgage, especially a fixed rate mortgage or a car loan, is a typical amortized loan. We can construct the amortization schedule for a $1,000 loan, which charges 10% interest rate every year with 3 equal payments. So we're going to pay off the loan in 3 years. That we can now calculate the amount of payment every year. Since the payment amount is the same, we can take it as an annuity problem. We are solving for the payment of this annuity. So with your financial calculator, you can input 3 as N, 10 as the interest rate, 1,000 as the PV. This is the principal of the loan, and we put 0 as future value. This means after 3 payments, we should be debt-free, or say there's no balance left. We compute for the payment, and payment is about $400. Next, we find the interest charge for year 1. This should be the beginning balance multiplied by the interest rate. So we started with $1,000 balance with 10% interest rate. That means the interest expense in the first year is $100. And since we are paying $402 plus 11 cents as the payment every time, then for our first payment, our principal portion of the payment is $302. This is after subtracting the $100 interest expense from the total payment. After we make this payment, how much balance do we still have? Remember, we started with 1,000, and the principal part is paid down as 302.11. Then that means our balance is left with 697.89. We can repeat this for year 2 and year 3 to complete the amortization schedule, which looks like this. So year 2, we start with 698, and we're gonna pay 402. And you notice every year the payments are the same amount. And 698 multiplied by 10%, that's why our interest expense from the second year now is 70. This is lower than the $100 from the first year. The interest rate is the same, but since the principal amount, or say the balance, goes down, then the interest portion goes down. And our principal portion actually now goes up. So interest payment plus the principal payment always equal to the total payment. So again, when the interest portion goes down, the principal portion actually goes up. After 2 years, our remaining balance will be 366, and this is after subtracting the 332 from the beginning balance at the beginning of the second year. So after 3 years, we pay off all the balance, and our remaining balance will be 0. And again, our interest expense is $37 now, 10% of the remaining balance from the beginning of year 3, and this is lower than the interest expense from the second year, and the principal portion goes up. So this chart just illustrates the fact that the interest payment declines because the outstanding balance declines every time. We can use a financial calculator for these amortization problems. Again, we compute the payment first, and then we can use the amortization function, the amort button in your calculator, and then we enter P1 and P2. We can find the INT, which is the interest expense, and we can also find the PRN, which is the principal payment, and BAL, which is the remaining balance. For details about all these calculations using the financial calculator, please check out the video I posted on D2L about the amortizations. The third special issue is about the fractional time period. That's when we do not have a whole year. So, for example, on January 1st, you deposit $100, and it pays a nominal interest rate of 11.33463%. and daily compounding. Then how much money would you have on October 1st, which is after 273 days? So this is not a typical future value calculation where you just calculate the future value after one whole year. What we can do is we convert the interest to daily rate. So stated annual interest rate divided by 365 every day, the daily interest rate is this much. Then we'll just use 1 plus I, 1 plus the daily interest rate compound for 273 days, and this is the future value after 273 days, which is the future value by October 1st. Using the financial calculator, we can use the daily interest rate, which is again the nominal interest rate divided by the number of compounding per year. So daily interest rate entered as IY, and we compute for the future value. So this is actually consistent with what we have learned. The only difference here is we're dealing with a daily compounding problem. For a summary for this lecture, first we try to compute future value or present value or interest rate or number of payments for single cash flow questions. And then we extend it to multiple cash flow questions. And when we have annuities, we know how to calculate future value and present value, and also payments for ordinary annuity or annuity deal. And we can also calculate the present value of a series of uneven or say unequal cash flows. We also try to deal with compounding frequency issues, so we can calculate the effective annual rate, and we can find out the future value when we do not have a whole year. And then we look at loan amortization and investigate how a loan is amortized over time, how to find the remaining balance of amortized loan. So these are all the contents from lecture 4, and again, these are not directly related to any case that you're gonna write report about, but for most of those cases you will apply what you have learned in this lecture and calculate either future value or present value of the cash flows. For example, the cash flows a project is expected to deliver